So this is a question from GATE 2025 from power system stability. So a generator is given which is supplying a grid through a parallel lines. So a triple LG fault, triple LG three-phase fault has occurred at that point. So first of all, the circuit breaker isolates the line. Then the fault is self-clears. Then the circuit breaker also restored or reclosed the line. It has asked the power angle curve basically. So there are three conditions are there. First of all, the before the fault, it is operating at steady state. Then previous fault has occurred. Then at the third stage, the fault is clear, the line is opened, the fault is cleared. Then the circuit breaker also restores the line. So there are four conditions. So suppose the reactance of the line, let's say it is X and X, and the generator reactance is Xg. So before the fault, the reactance will be Xg plus, as the lines are operating at parallel, so the reactance will be X by 2. Okay. So the maximum power will be EV X1. Now during the fall, the reactance will be infinite. That means the maximum power will be 0. After the fault, so this circuit breaker CB1 and CB2 will be opened. That means this line will be not there. This line will be not there. Only this line will be there. So the reactance will be only X. That means the maximum power X3. And this power will be less than the Pmax as the reactance is more now. Okay. So now let's try to draw the power angle curve. So initially, so this is the steady state curve. So this is the isolation after the isolation of the line. As the Pmax is less than the, as I told that PM3 is less than PM1. So it will be less than PM1, PM1, PM2. Okay. Now suppose this is our mechanical power PS. Okay. So it is operating normally at steady state. It is operating at this point, and at this point, PS equal to PE. And when the three-phase fault has occurred, the electrical power will become 0. So it will become 0. Okay. So now that let's say the angle is delta naught, the power angle curve, the rotor curve will not change instantly. So the angle between the rotor and the synchronously rotating axis will not change instantly. So after the fault has occurred, the rotor angle will change gradually. So suppose at this point delta CR, the circuit breaker isolate the line. The circuit breaker opened CB1 and CB2. Okay. So the now the our operating point will move to the third condition. That means this blue line. This now the operating point will move to this point. Okay, the second curve, and it will operate in this curve for a duration. Now, also in the question, given that after the isolation of the line, it has restored and reclosed the line. That means the original condition, this condition has been restored. After, let's say, again at delta 2, the original condition has been restored by the circuit breaker. That means again the impedance is x1 and the operating point will move to the original current here. Now we'll see the area between PS and P. Okay, PS and P. Now initially the area between PS and P during fault will be this area. This area. Okay. Now again this in the second condition the area with the P moves to this here. So the area will be this area. Okay. And after the reclose of the line, the area will be this. Okay. So if we compare this diagram with the answers, we'll see the B option is appropriate, as you can see here. So the answer will be B. So that's how to tackle this type of question. We have to draw the power angle curve, and also different conditions have to be plotted. And this is how this question is done. Thank you.